Taking a look, it's going to get a little bit harder. I'll do D with you, but I'm going to have you guys do E and F on your own. D is a little bit harder because we're dealing with negative exponents, but this actually is going to help us a lot because remember that x to the negative 2 is really just 1 over x to the positive 2. That when you have a negative exponent, really all it means is that it was a fraction. And it had 1 over x to the power of positive 2. So if you ever have something that looks like this, it is a polynomial function. It is a function of this form. You just need to know that you put it into a negative exponent in order to then process what the derivative would be. So this is one of those tricks that you have to remember to manipulate your equations when you're solving for the derivative. This is one thing that's available to you, is that if you just take this fraction guy and turn it into a negative exponent, that you can still find the derivative of that function. It's just a tool, a process you can follow. So we still do the exact same thing, that your derivative is equal to, okay, well, you take the exponent and you multiply it by the coefficient, which is 1. So it becomes negative 2x, and then negative 2 minus 1. Just realize it gets more negative, so it goes to negative 3. Negative 2x to the negative 3. We're going to do a little bit more manipulation to just show you like the process that goes through this. This is kind of why we learn about negative exponents and why they're so important. So that just realize that this negative 3 is only applied to the x, not to the negative 2. So I can think of this as negative 2 times 1 over x to the positive 3, right? Just converting this guy into this guy. And then that negative 2 just goes on top. You can think of it as negative 2 over 1. So sometimes your derivative ends up looking like this when your original function was that. And it's just because the relationship of negative exponents to this fraction form. Okay. I would like for you to try E on your own. Multiplying the coefficient and the exponent, I get that the derivative is equal to negative 1/3 times 3 is negative 1. So just negative, and then x, and then 1 less than positive 3 is 2. So negative x squared. I'd like for you to try f on your own. It doesn't matter if you have a different variable, st, xy, it's the same. Taking your coefficient and your exponent, multiplying them together, it becomes negative 10. 2 times negative 5, negative 10. T, and then 1 less than 2 is 1. We don't really put a 1 up there. We tend to just leave it blank, and that's your derivative. So your first entry into finding derivatives algebraically using the power rule, pretty straightforward, and it stays like this for the rest. It can get a little bit more complicated, but the really cool thing about derivatives, and the further you go into derivatives, the more you realize you can like split up equations in this way, is that if you want to find the derivative of something that looks like this, you just deal with each term by itself. That then g prime of x is equal to how do I put this? Like x to the 4th prime, the derivative of that, plus negative 1/3 x cubed prime, just the derivative of that, plus 10x squared prime, plus 15 prime. So really what you're doing is just taking this little bubble and saying like, what's the derivative of that? What's the derivative of that? What's the derivative of that? And what's the derivative of that? So practicing it, notice we just did these derivatives up above. It's all coming together, full circle. The derivative of x to the 4th is 4x cubed. The derivative of negative 1/3 x squared is negative 1/3 x cubed is negative x squared. So I'm going to do minus x squared. The derivative of 10x squared is 20x. Let me just double check that I wrote that down correctly. I did. Plus 20x. And then remember that the derivative of a constant is just 0. because the slope is 0 with the horizontal line. So you can do plus 0 here. It all comes together. To look like this. And again, realize that this would have been considered a quartic function because its highest degree is to the 4th power, and so its derivative is still a cubic function. It's just a cubic function that looks a little bit more complicated. All right. The next two are going to be ones that are exactly what we just talked about, that you can just like split each of these guys into sections and figure out what the derivative of each of them is. And it's just practicing a little bit of tricks and a little bit of manipulation of like harder problems that you might come across. So breaking it down, the derivative of 5x squared is going to be 10x. The derivative of negative 4x is just negative 4. And then I want you to think about 8 over x, about what we talked about on the previous page. That sometimes it looks a little bit like this, and we don't like to think about it in that way because it gets a little complicated. So instead, we need to think about it in this way. So I want you to tell me what the derivative of just this piece right here, what is the derivative of 8 over x? If I tell you to think of it as 8x to the negative 1, right? Taking this x and putting it up top takes the positive 1 aspect of the exponent and turns it into negative 1. And that way it looks just a little bit more like something we can handle using the power rule. So I would like for you to tell me, what is the derivative of 8 over x? It ends up being negative 8x to the negative 2, right? Negative 1 times 8 is negative 8, and then you get 1 less than negative 1, which is negative 2. I could rework this to be 10x minus 4 minus 8 over x to the positive 2. So notice that when it's in the denominator, instead of the exponent going down by 1, it looks like it goes up by 1. But it's just because of the behavior of exponents and negative exponents that mean, hey, when it's in the denominator, really it's this negative exponent, which means you're still using the power rule and you're 1 less degree. It just looks like it would be more because it's in the denominator instead of the numerator. Okay. So that's one trick, that when you have an x in the denominator, you need to think about it and convert it into a negative exponent situation in order to know what to do. You could have left it like this. I'm okay with that. I would still give you points for that. But if it asks for it to specifically only have positive exponents, then you would have to know that you would be putting it into this fraction. So if it asks for only positive exponents, you would have to convert it into this. But if it doesn't ask, you could leave it with the negative exponent. Okay, last one. Another way that we have things that are a little bit more complicated is that sometimes we have fractions, and we know that fractions freak us out. But if we thought about it instead as breaking it up, instead of one big fraction, to break it into smaller chunks, right? Having small pieces that we can handle, we can do that with here. Remember that x over 5 plus 3 over 5 could become x plus 3 over 5. So if I wanted to go backwards, I really just take x over 5 plus 3 over 5, and I can split up a fraction that looks like this. I like to think of it as a heart, to become 2 smaller pieces that I can then handle. So we can do that here. I can break this up using my heart as x squared over x plus 5 over x. So you can manipulate an equation to make it look like a way that you can handle it. X squared over x can simplify down to x, right? Remember that this would become a subtraction of your exponents. So 2 minus 1 becomes 1. If we're struggling on our exponent laws, definitely look up like IXL or Khan Academy and look at and remember what your exponent rules are, or look at the notes that we took at the very beginning of your 11th grade year. This you can then think about also as 5x to the negative 1. So now I have it in this form, much easier to think about, well, what would our derivative here be? And you can see how we can move from here. So your derivative of h of x is equal to, the derivative of x is 1. This then becomes minus, because 5 times negative 1, minus 5x to the negative 2. I could rewrite it as 1 minus 5 over x squared, and you could leave it like that. And there you go. So the idea of the power rule is pretty straightforward. The hardest part probably about finding derivatives is just being able to manipulate an equation in order to be able to apply the power rule. So dealing with negative exponents, turning these denominator x values into something that we can handle, and knowing that you can split up fractions to keep it into chunks and be able to deal with each chunk at a time as opposed to this big whole mess. All right. Good job today.